Here we are. This is CNIT 50, so it's Splunk today. I'm going to cover a couple more chapters from the book, and then I'll do more demonstrations. The demonstrations should move more smoothly this time because I'm not using a virtual machine. At the end of class, somebody finally reminded me the way to make Splunk work on a Mac M1 is just to install it directly on the Mac. Then it runs fast enough you can get things done. So we'll get to that, but we're going to start with Chapter 7, which is here. So, some best practices. Time, they say, is the most efficient filter. If you can limit it to the last 7 days or some time period, then you eliminate an enormous number of events. They always recommend specifying the index. If your data is in fact sorted into indexes, as large companies almost always are, and then include more search terms. I mentioned this before. The speed of the processing depends on how many answers it finds. So the more you restrict it, the faster it'll go. Be as specific as possible. And inclusion is better than exclusion. Looking for something like access denied is much faster than searching for not access granted because, of course, not includes every other possible thing. So that's going to have more results, and it's going to take more processing time to find those results. So you filter as early as possible. Avoid using wildcards at the beginning or middle of a string. At the end of a string, it's much safer. Fail star, because then it can just look at a word, look at the first few letters, and immediately exclude it because it doesn't have any word that starts with FA, so it never really has to worry about the star, except for the few cases where there really is the word fail. So, and they say or is better than wildcards, of course. With a star here, that includes a large number of possibilities. If you were to list options here with or, that would be faster. And like I say, they worry about CPU time. Now, in our case, we have our own server, and my Boss of the SOC server is not having that many people using it, so you really don't have to worry about computational speed too much on ours. But anyway, here's the index. So index equals security, index equals sales, or index equals web. That's what you'd put in if you have data in a large network separated into different categories. That'd be a way to limit it to look only at the right stuff. You can use stars in index too. Index equals star. That'll, of course, be slower. And you can search without specifying an index. And they don't like it, but it's often what I do in these test cases that we're working with. So the index field might not show up in the search results, but you can search without one if you have data that's not indexed, although the Splunk people don't like that. So there is a search language, and there was a student here talking about this. If you know databases and you know SQL, the standard search language, that's what Splunk is using, a version of that. Now, this is a search with all the advanced search components. So this is just basically the same as Google Advanced Search. That's why, Splunk is often called Google for log data. That's pretty much how it works, which is why it's so easy. So you search for something, source type equals access star. You pipe, that's going to take these events and pass them through some kind of processing, like do the sum of price. So it's going to do a total of a field. And then that gets a sum. And then it's going to print out, instead of just summing all those events, it's going to show a chart as lost revenue, or it's going to rename it. It's going to rename the sum lost revenue. Then it's going to evaluate lost revenue equal dollars, and then to a string lost revenue with commas. So this is just how you format it to look like a nice, pretty money dollar sign and such. So this is an example of how you would build a search. And so you got search terms, the things you're looking for, then commands that do things like create a chart, or functions that will do things like get a sum or an average. And then you can have arguments where you calculate the average value for a specific field, or clauses that group or rename them. All right, so there's your search pipeline. You have the basic data, then you fetch events that match. That gives you intermediate results. Then you go to a top user. That's going to take the most popular 10 events, top 10 users, and then remove the column showing percentage. So, this is how it works. This is, by the way, how object-oriented languages work in general. This is how PowerShell works. This query creates an object, which is a table, and these other ones process that table further. Let me check for comments in the Twitch. Nothing new. All right. So, So if you want to make the pipeline more readable, instead of just having a horizontal line with a pipe, you can put a carriage return at the end of each pipe. That's another way to do it to make it a little more easy to read. All right. And some parts are automatically colored as you type. The rest of it remains black, so the or and will turn orange when you get it in there correctly, which is a tip. And other things change color, like commands are green, functions are purple. Command arguments are green. Well, that sure doesn't look green to me. That's an argument. And commands are blue. So these two arrows are pointing in the wrong place. I wonder if I can move them. Yeah, I can move them. Ooh. If I can get the arrow to move. I may not be able to fix it. Nope. Anyway, those two arrows aren't going to the right place. So, all right. So you can turn off the automatic syntax coloring. There's an option if you care about that. Like I say, it has all these graphical, beautiful things I don't use much. And table, we've already used this in the Boss the Sock. Table is very nice to give you a table of data. So here you have index equal web, source type equal access combined. And you can make a table of it all, which somehow is not showing up here. Well, it should, I think. Anyway, we'll have an example of this when we get to the Boss the Sock. We've already done it that way. And you can rename fields. If you don't want it to have whatever the default names are, you can rename them. So you can rename product ID as capital product ID and so on, just to give it more decorative names. Once you rename a field, though, it affects the database, so you can't access it with the original name. So here, I do take index equal web, then I make a table with client IP, action, product ID, and status. Then I rename product ID as product ID with capital letters. And now I rename action as this and HTTP as that, which is fine. But now if I do all that, and then I try to make a table, here I'm going to get no results found because action status is HTTP status. I feel like something's missing here. But anyway, the point is after you rename it, you have to use the new name, not the old name. If you have something referred to the old name of product ID, it wouldn't be there anymore. All right, there's an example of a table, which is fine. So you name it, action is customer action, and status is HTTP status. Now when you make a table, you have to use the new names. And I think this one is supposed to have that table line at the end, and somehow it's not showing up. I had to convert these slides, and it looks like they got distorted a little bit in converting them to Keynote. Anyway, fields lets you extract things from a search. You can exclude or include specific fields. So fields plus will include, and fields minus will exclude. So if you do a query that has an answer, and then you exclude fields, it doesn't save you processing time. It had to do the query to create the object that had that data, and removing it before you display it doesn't save time. But if you do this before extraction, that improves performance.
And Sam, when we're doing those actions where we're clicking on the search results, do you use add to search minus search? That's what's happening there. They're adding those fields to the search.
Well, those are usually adding words to the search, which will restrict the results. This is talking about.
Sorry, I came in late.
Yeah, that's right. What they're talking about here. There should be an example of fields coming up. Yeah. So here you go. Display network failures. Well, they don't seem to have an example of fields. It's a good question. Well, let's wait and get an example. I think it'll be one we get to the hands-on part.
Sure, yeah.
Because I never have used it. I never care about this. These are decorative things that don't affect the meaningful result. But all right, only specified fields extracted. Fail star or invalid. Yeah. All right. Anyway, dedupe will remove duplicates from your result. That's reasonable. So here you've got a search result that has duplicates. Like these two rows are completely duplicates. Beantown Games, Boston, Massachusetts. And so what you've got here is source type is vendor sales. Vendor is BEA star. So it gets various vendors that start with that. Then you make a table of vendor, vendor city, vendor state, province, and vendor county. So this is a table, but you got duplicates. So you could dedupe by vendor before you make the table, and then it'll get rid of the duplicate records. You could also dedupe by vendor and vendor city, and then those would both have to match to remove records. So it's going to allow you to have beach games and beach games because they're different cities. So that makes sense. Standard database thing. All right. And you can sort.
Did you talk about why we're making these tables? Is it essentially to pivot the data, kind of get a more global view?
Yeah, just how you track down things. And we'll use them a lot in Boss the Sock. You'll see. You find, like, if you do get login events, you get a bunch of them. Then you somehow want to get the ones that are a brute force attack. Then you want to order them. And another thing we're going to do is you get events that execute code, and you want to get just the code to see it. There's lots of reasons why you might do this. Yeah, just to zero in on something of interest.
Yeah, we've already talked a little bit about refining results and which results to go after first and things like that. I'm just trying to understand more context.
Yeah, and for business, there's a whole bunch of stuff just to make it prettier, which is important in corporations for management. So management can have a nice, beautiful chart.
Even if they don't understand it.
That's right. It's a big part of business. So you can sort things. You can sort them ascending or descending. All right. Well, I can hear you're sorting by IP and URL. Ascending IP and descending URL. Put a minus in to get descending. That sort of thing. And you can limit the number of results. You can sort by this and then have a limit 20, so it'll just give you the first 20 results after doing a sort like that. All right, so you can sort plus or minus by field name, and there's something about a space. Plus a space and then the field name applies to sort to all following fields. I see. This would be, I'm not seeing the sort fields in my examples here for some reason. What if there's, nope, no, somehow these sort examples are not looking good. We'll get to it in the hands-on part of the project. All right, anyway, so that's 7 and 8, and I think I was supposed to talk about 9 too. It's, yep, all right, let's take a look at 9, and these will be a lot more clear when you get the hands-on where you do this stuff. So you get top values, just pipe to top, it'll give you the top 10 by default and give you a table. And let me try the PDF version of this, because so many of these don't seem to have the right data in them, which is very strange and didn't happen to me before. Let's see if the PDF looks better. Let me go down to 7 here. It seems like a bunch of those are missing the actual information we need, so let's get down to, here's 7, okay. Here's 8, yep, okay. So, all right, this is not too bad, although it might not be streaming, right? That might, oh, that's right, there's this issue of size. What if, there, okay, now, all right. Yeah, here's the renaming. So rename action as customer action status by HTTP status. I think that some of this stuff has been cut off before, so let me just stick with the PDF. Here we go. Yeah. So there's a table. There's a table making action status, and this is what I wanted to show you. You renamed action as customer action, so now when you make a table of action status, you don't find anything because that is no longer there. You have to use the new name because this affects the data object. All right, this is better. All right, and now here, you've got index this, then the fields command is here. There we are. So here you get all the data. Here you're only going to print certain fields. So over here.
So it's actually coming out of the log, selecting just user app source underscore IP.
I think so. So user app source IP. But I'm seeing failed password here. That's why it looks identical to the one above it. So I think there's still something wrong here.
Maybe they just got lazy cutting and pasting.
Yeah, I think there's this should only have those 3 fields. Anyway, that's why I thought even the original has some flaws. And here's dedupe, which we talked about. That worked. And here's sort, limit equal 20. And there's the sort. The sort lines are somehow vanished from my other one. So here you have. Get some records, you dedupe by vendor, vendor, city, you make a table of vendor, vendor, city, then you rename them, then you sort by vendor and vendor city. Right, it's not renaming, these are 4 fields. So you have these 4 fields, and then you sort by vendor and vendor city. So the vendor should be going up, oh, negative, down alphabetically. So beach and beauty, right, it's negative alphabetic, and this is positive alphabetic. And if you put a space after the sign, it'll apply to all future fields. So here's the same thing as the one before, as far as I can tell. But the let's get down to here. Yeah, there's supposed to be a, oh, here, that's a space. Okay, so now I sort negative with a space. So now it'll sort reverse alphabetic for vendor, and this should be reverse alphabetic, but it's not. So again, their fixture doesn't match what it's supposed to be.
Well, it's changed because
no, it was Butte.
Fort Lauderdale it's swapped. See that? Beach games have Miami and Fort Lauderdale swapped.
Well, that's weird, but this is not this is not in alphabetical order at all now.
No, I see that.
Which is not what was supposed to happen. What they said would happen is put a space applies the sort order to all following fields. So it should sort by reverse alphabetic vendor and sort by reverse alphabetic vendor city, but it seemed to just not sort by vendor city at all.
Yeah.
So we might try that when we get the hands on and see if it actually works. Either this figure is wrong or the figure doesn't quite work right. Both are possible. Nothing is ever perfect. All right. Anyway, then there's transforming commands. Top shows you the top by source IP. So you see the most source IP with the most events going down to the top 10. And you can change that limit with limit count field, and you can tell it whether to show percentage instead of a count. So you'll see that here. Here's top value. That will just add it there. And then you can have a limit equals 20 and a category ID. You can type these in. I don't think there's a way to get these things in the GUI. All right. So if you do top for a single field, you control the number of records with limit, and limit equals 0 is how you get them all. So here's top limit equals 5, giving you the top 5 events. And there is a way to get a pie chart, although we're not doing that yet, but they're showing one way to get there. All right.
Sam, sorry, just for workflow questions. Are you using these tables actually as part of the investigation, or have you already investigated and this is more sort of presentation events?
You do both.
We kind of know what we've done, and so we just need to make it clear to people who don't use Splunk every day.
You use them for both purposes. So often tables help you in the investigation by just cleaning out the data and getting what you need. When you're going to show it to other people, this kind of pie chart stuff is often quite helpful.
Right.
Yeah.
So for this table, if we were doing an investigation looking at these events, we're prioritizing the most frequent events first?
Yeah. That's often what you do. You're looking for, you're doing threat hunting is what you're often doing. You're looking for trouble and you don't know what you're looking for. So you find something suspicious like some kind of failure, and then you look for the most common events, seeing if a lot of failures have something in common, like they're all coming from the same IP address, they're all in the same time range, that sort of thing. And that could be an attack, or it could be like a defective product that broke, that kind of thing. Good. And so you can use top on multiple fields. So here we are using top on several things: CS username, X, webcat, code full, limit equals 3. So now it finds the combination of these two fields that have the most events and sorts by it. And so the first two, I guess they're all three different, but anyway, these could have two the same, and that would be different, and would still be counted as a different row.
So webcat is just a command from the concatenate version?
No, that's the name of the field.
Oh, okay.
Yeah, that's the name of the field. Yeah,
yeah.
Just the name of a field in a database. So it's not a command you'd be able to use elsewhere. And you can have a single field with a by clause. So I'm going to do top webcat by username. And now you get the top webcats, and you group them by usernames. This username has those 3 webcats, and these other usernames have others. So that's a way to make this combination chart, which is often extremely handy when you have 2 parameters, and you want to group by one and sort by the other.
So what this is saying is we have acurrybuttercupgames.com.
Yeah.
Is making the most attempts or the most events.
Yeah, these are the top 3 webcat codes that this person did. Mm-hmm. And these are other people with their webcat codes. And apparently it's by name, because this guy has computers and internet was one of their top ones, and it wasn't here. So for each username, find the top 3 codes.
So these aren't the most frequent usernames. These are just the top events that usernames are using.
Yeah. So you'll have
these attempts.
Yeah. So every username should be here, and their top 3 events. Yeah. Exactly. This is a really common query for a lot of purposes.
Can you refine the query to do what I just sort of described, where you could get the most frequently used? I don't know why you would do this, but it's just a question. The most frequently used usernames and their top fields. Can you do those kinds of combined queries? Or?
I think you'd have to do those in 2 separate stages. At least that's how I would normally do it. Right. And so here you can rename the count field. You may notice the field here is called count. You could give it another name, of course, just to make it pretty. Count field equals string. So you can call it total viewed by putting count field equals total viewed, of course. They really did some renaming stuff in Splunk. And of course, if you want rare events, you use rare instead of top, and the syntax is otherwise the same. Those are the least common events, if you want those.
Why would you want those?
Oh, it's a good question. I don't know if I can make up a scenario. I mean, certainly the mathematical option is there.
Sure.
You might say that anything very common is probably legitimate business as usual, and the rare events are more likely to be the flaws or the attacks, that sort of thing.
Okay.
And probably could come up with a better scenario. But I don't think I've ever used this in Boss the Sock, though. But it's there.
Got it.
Yeah. And then you got stats, which is all the stats you might want. Count, a distinct count counting unique values, sum of values, average, list them all, and just list the unique values, various ways to summarize fields. And those are all quite useful. So here we're going to count the number of matching events. So we have some criteria and then the count. So we get one number, 380. And here we're going to count and rename it potential issues, 380. Here we're going to add a field as an argument to the count. So now we're going to count as total events, and we're going to get the count as action events, but count vendor action. So now it's going to count that specific field. Now the reason this matters is if that field is missing, it won't add to the count. So count would just count events, count vendor action will count just the events that have a vendor action. All right. And you see that here, 52 and 59, you have vendor action has 52, but there's total of 59 events. So there's some that didn't have that field. So they appear in that total, but not in that one. And you can do stats by field. You can do count by user app vendor action, and then you'll get all the unique categories of user app vendor action and a count of how many each those combination checks get appear. Yeah.
Sorry, just going back one slide to where you pointed out the differentiation
Yeah.
between what appears and what doesn't appear.
Yep.
From a workflow perspective, let's say you have zeroed in on these two headers, that you're interested in, count vendor action and whatever else.
Yeah.
Are you making notes then to say, okay, we got 52 of these, we have 59 that we want to go back and look at later, but we don't know what they are right now, but we're focused on 52.
Yeah. You keep notes of that if it matters. And you do have to keep notes whenever you're doing this kind of work. Because the main thing you do is threat hunting, so you're looking for anomalies, and you'll just keep track of things you find and somehow mark the ones that seem interesting, and you may pass them off to an analyst to go into more depth or something. It's detective work, You look for things that catch your attention and follow them up, and then you might go back and try the other ones that caught your attention before.
Right, and what I'm just getting at, just to drive the point further home into my brain, is that you're essentially putting these things into different buckets to know where they are,
Yeah.
and then delve into the buckets
Yeah.
further later.
Yeah, and I did this stuff for a living for many years. I remember one of my cases was a fertilizer case. It turned out that the farm fertilizer manufacturers were engaging in price fixing, illegally collaborating to raise the price of fertilizer. So we had about 10,000 farms that were getting refunds for the amount they'd overpaid. But the farms were huge, like a square mile, and they would have like multiple offices in the corner. And so there'd be like 3 addresses to different addresses with different names of the person that are all the same farm. So you really shouldn't get 3 checks. So we had a lot of stuff we do trying to find the duplicates, try to find them in the same zip code, and you would make weird combinations. Like one of our favorite, another huge problem is, a list of people change their name and they abbreviate their name. So again, you might send them 2 or 3 checks thinking they're 3 people when there's a lawsuit. So we had combinations like first 3, last 5, address 11 to try to get a identifier that would catch the duplicates. And so you'd query by this field to find things that appear to be the same, and then you'd make lists of them like this, and then you look through them by hand. Is this really the same person or not?
That's crazy.
But it was a big part of the job was deduping. This is true of everybody. If you have, like they used to mail catalogs in the mail, and you would often get 2 or 3 of them, because they would buy lists of customers and they try to combine them, but your name would be a little bit different. And so they weren't able to successfully dedupe it. This is a huge problem for all database handling. I think they call it data science now. And I did this for years, trying to massage data into a good format. And sometimes you can't do it. Like we had a case for the people were in prison and they had been forced to work on something and ripped off. And so they're going to get money back for the work they did in prison. But it turned out that an incredible number of people in prison have lied about who they are because of the 3 strikes law. They've already been arrested twice, so when you arrest them again, they use their friend's name and social security number. So even social security number doesn't really uniquely identify them. There are different people that are using the same. The same thing's true of illegal immigrants. You had a case for people in Albuquerque were the transient farm workers, and they were getting poisoned by the water supply that was polluted by Motorola. And they asked me how many victims are there, and I couldn't even get close because they'll have a house with like 20 people sharing it, and they come and go, and they only have 3 IDs. So whoever gets a job today, okay, you're Carlos today, or you're Carlos tomorrow. And so you can't count the name, you can't count the address, you can't count social security numbers. You actually have no idea how many there are. And good luck ever finding them, like a year later, to pay them something. It's a problem, you know. It is a huge problem. You get data, you have to deal with these errors and duplicates, and often it is very difficult.
It's so annoying to me because I hear anecdotes like this, and I think about how much we're all bogged down.
Oh yeah.
And then the current situation, like, it's all just this big distraction to bog everyone down so that these people can get away with ripping us off.
Yeah.
Even more.
Oh yeah.
And we're not going to find out, if we ever find out, for decades.
Well, right now, that's one good thing about the Trump administration. You do everything right in front of you. They're not hiding. They're not hiding a
so
thing.
Much of it you can't stop it.
That's right. Well, we'll see. The courts might stop it, and right now it's pretty crazy. Anyway, so you can do statistics by field. So you do a count, but instead of just doing a count, you do a count by user, app, and vendor action. And so you get each unique combination of those and a count of how many times that combination happened. So that's quite useful. And you can do a distinct count, which will give you counting unique values instead of just the total count. So if you have 10 values that are the same, it'll count as 1 instead of counting as 10. And either one of those might be what you want in different circumstances. And then you can sum a field. If it's a numerical field, you can sum them up, get the total amount of something like bandwidth, counting bytes. And you can have multiple functions. So you can count price as units sold, sum price as total sales, and break it up by product name. So you get the units sold and total sales, both from the same thing, adding the price. Counting the price and adding it are 2 ways of measuring data. All right. And you have averages, of course. You can average anything you want. It looks to me like there probably is some way to round it off, which is certainly what I would want to do. There is some way to specify the round off. There was an example about 10 slides back.
You don't need the 8th decimal?
Yeah, I know. I know.
Specificity matters.
Well, yeah, that's my first thought. Anyway, there is a way to round it off. There was one a few slides back that showed how to make it dollars with cents. So that would be my move here. Yeah. I wouldn't hand this to anybody.
Maybe click that pencil icon.
But I would get this to have commas and only 2 places or something. Otherwise, you look like a fool. All right, and you can list the field values. This will list all the values. So here it doesn't count them; it just lists all the values. So I'm listing shostname, call as websites visited, by username. So for each user, I'm going to list all the websites they went to. Now this is clearly useful for security. Like you could have your DNS records. You could see which people are goofing off, playing games, going to porn sites or something. Yeah.
Now, are those logs only taken from what they visit on the network that the traffic that you own comes from, or can you get where they came from and where they leave to?
Well, this is actually a huge issue. I mean, if you are just thinking about your own network, you'll only have logs of yourself, but people use proxies and they use services like Cloudflare and OpenDNS. So you take all your company traffic and send it to some web place, and they might be using it. In fact, they often are. Especially the cheap VPN providers are often companies that used to be making malware. They're basically criminals, so they probably are just collecting your data and selling it, or exploiting it in other ways. This is actually the huge issue. This is what they call the economics of privacy invasion. There's a word for it, market in privacy capitalism or something. There's a famous word for this, how everybody spies on you and they make money selling it, which is why, for example, I asked this for years, why do I have 25 or 50 apps on my phone? Why don't I just have a browser and go to 50 websites the way you do on a desk? And as far as I can tell, the answer is every one of them wants to collect all that data to sell it. That's how they actually make money.
Have the little thing you never read and you check yes before you.
That's right. And I remember Papa John's, sort of like the Trump administration, let the cat out of the bag, because Papa John's is Christian and they close on Sunday. So just for marketing, they decided what would make a fun commercial is show where everybody eats on Sunday when we're closed. So they just put up a map of here's our 1 million customers and here's where they all went, just revealing what you probably really didn't want to tell them, that you're spying on everything they do. You know where they all are. Just because they have a Papa John's pizza app on their phone, you know everything everywhere. They probably really didn't want to advertise that, but they did.
not just your pizza data, we're getting all of it.
Yeah. And that
so-
data is apparently worth a lot, and they resell it over and over. That's why, when they said they're going to ban TikTok because then China will have our data, they say, who are you fooling? 100 people have our data anyway.
Yeah.
Data brokers.
Yeah.
Every day,
Yeah, data brokers are selling it to everybody. And in fact, the thing is, the ads in the browser, every time it loads an ad on your phone, it sends a bid request to 200 agencies saying, hey, somebody's opening a web page. You have 1/10 of a second to say how much you'll pay to put an ad on the page to guide you. Here's a bunch of facts about this person. Here's how old they are. Here's their location. Here's how much money they make. Here's what their interests are. So how much will you pay to put an ad on this page? And somebody bids the most and their ad appears on the page, and this takes less than a second, but there are people who just harvest the requests to collect all that data about people.
Well, I mean, every single Google search now that you get is an ad,
Yeah,
and there is a whole bidding system going on in the background.
There is.
that nobody thinks about.
this is why Google is rich, because it used to be the way to advertise is to go on like TV or the newspaper. And so you put an ad, a Coke commercial on the TV, and you really don't know how many people saw it, and you really don't know how many of those people bought Coke. But if you put it on the web, you can measure how many went to the website, how many bought the product, so it made it scientific. And that's why they
and
basically,
then they reversed the scientific aspect and made it into an auctionable value
Yeah.
asset.
That's right.
So they basically, and the buy box
Yeah.
on e-commerce is also the most
Yeah.
evil invention with
Yeah.
our data ever.
Yeah, the technical term for this is surveillance capitalism. That's the term.
We know
Anyway,
what you want. We know what you're going to do. We're going to make you do it.
yep. Anyway, so that lists the fields, and you can list the unique values for the field. So this was a list of all the appearances of this field, but I think it's possible for it to have duplicates is the idea. This one will give you the unique values for the field. And you can format these tables. You can color code the data and so on. And you can click the pencil icon where you wanted to click, and that will give you some formatting options, which I've never played with much because I don't care. But, when you want to make a report for management at the end, these colors would help. And so here's some examples of formatting tables. You can choose minimum, midpoint, and make it look like this. Oh, you put the shading in. So the one that's important is colored in. And then you could here's their 1,000 separators and the units. And I would imagine there's some way to turn on the commas. So now you can format your numbers so they look better. Now you can have euros. So this is friendlier, of course.
And now we get rid of those 19 decimal points you showed us earlier.
Exactly. Yeah. All right. So that's what I wanted to show you as a general description. I'm going to show you the hands-on part. Let me stop this recording.